Let's look at exercise 9 from the section 2.6 worksheet. How many cups of pure water should be mixed with 3 cups of a 30% acid solution to dilute it into a 5% acid solution? All right, now we're talking about pure water, 30% acid solution, and our mixture, which is 5% acid solution. And this is the resulting mixture from mixing water and 30% acid solution together. So one of the things that we're going to be interested in is the cups of solution that are available. So in the case of the water, we don't know how many cups of water we have. So we're going to let that be represented by our variable. We're trying to find out how many cups of water we should use. So that's our x, our unknown. Now in the case of the 30% solution, the problem tells us that there are 3 cups of 30% acid solution that are going to be used in this mixture. So when I mix my x cups of water with my 3 cups of 30% acid solution, I'm going to have x plus 3 cups of the mixture that I form. So if you're mixing two things together, however many cups of the one is added to the cups of the other, the sum of those two amounts is going to be the amount in your mixture. Now another thing we're interested in are the cups of acid that are in each of these solutions. I'm referring to water even as a solution. If I have pure water, I'm assuming that that has 0% acidity. So that's the thing to keep in mind. Pure water is 0% acid. That's kind of a unstated fact in this type of problem. So pure water has 0 cups of acid in it. The 30% acid solution comes to us in, we have a total of 3 cups. 0.30 times those 3 cups is the actual cups of that are acid. So notice that's 0.90 or 0.9 of a cup of the 3 cups is actually acid. So if you could separate the acid out from the solution, 0.90 or 9/10 of a cup of that would be acid. The other 2.1 cups would be something other than acid. And then in our mixture, we want that to be 5%. So 0.05 times the cups of this 5% solution, which there are x plus 3 cups of those, will be the actual cups that are acid. All right, so we take the concentration, which is given to us in a percentage, and we multiply that by the number of cups we have of that solution to get the cups of acid. Okay, so now our equation comes from adding the cups of acid in the water, 0 cups, plus 0.90 or 0.9, it's the same as 0.90, and that has to equal our 0.05, that has to equal the acid in our mixture. So when you mix these two things together, you're adding the cups of acid in the two things to form the cups of acid that are going to be in your mixture. So we have 0.9 equals, and we're going to distribute this 0.5. So we have 0.05x plus 0.05 times 3, which is, next line, we get 0.9 equals 0.05x plus 0.15. And we want to solve this for x. Now, it may actually help us in what we need to do to attach. It's not necessary, but it may help make our next step a little more clear. Let's add the 0 on the end of that 0.9. Let's write 0.9 as 0.90. Those have the same value. And the reason I'm doing that is because we're now going to subtract 0.15 from both sides of the equation. And it helps for these decimals to have the same number of digits to the right of the decimal point. And we can always get that by adding as many zeros as we need to the expression that doesn't have enough digits to the right of the decimal point. Adding zeros doesn't change to the right of a decimal, doesn't change the value. All right, so we have 0.75 on the left equals 0.05x, and that's on the right side of our equation. We're going to divide both sides of this by 0.05 in order to isolate x. And we find that x is equal to 15. So 15 cups of water should be mixed with 3 cups of 30% acid solution to dilute it to a 5% acid solution. And that's how you would work this type of dilution problem. An important point is that you realize there is no acid in the pure water. And that's an important point in a dilution. But remember that 0 comes from multiplying 0% times your x cups of water.